In this lesson, we're going to focus on mutually exclusive events. Now, what is a mutually exclusive event? So these are events that cannot occur at the same time. So what does that mean? Let's say if we have two events, event A and event B. Events A and B will not occur at the same time if they do not share any outcomes. Now, what we're going to do is illustrate this with an example. Let's say we're rolling a 6-sided die with a sample space of 1 to 6. And let's say that event A represents the outcomes 1, 2, and 3. And let's say that event B has the outcomes 5 and 6. Whereas event C, we're going to say, has the outcomes 3, 4, and 5. Now, here's the question. A and B, are they mutually exclusive events? What would you say? What is the sample space of A and B? What is the intersection of these two events? Notice that they do not share any outcomes. So there's no intersection. Therefore, the probability of A and B occurring together is 0. This cannot happen. Let me write this as A and B, because you might think it's A then B. So make sure you understand this. The probability of two mutually exclusive events occurring is always going to be 0. Now, what about events A and C? Are they mutually exclusive? Notice that A and C, they share the outcome 3. So the intersection of these two events is 3. So the probability of getting A and C is going to be this one outcome over the 6 possible outcomes. So because the probability of getting A and C is not 0, A and C are not mutually exclusive events. However, A and B, they are mutually exclusive events. Now, what about events B and C? Are they mutually exclusive? B and C, they share the outcome 5. So that's the intersection of these two events. So that's the probability of getting B and C is going to be the same. It's 1 over 6. So because it does not equal 0, we could say that B and C are not mutually exclusive events. So that's how you can tell if two events are mutually exclusive or not. You need to find the probability of getting those two events. If it's 0, they are mutually exclusive. If it's anything but 0, they are not mutually exclusive. Now, let's illustrate the concept of mutually exclusive events using Venn diagrams. So let's say this is event A, and on the right, event B. So which Venn diagram would you say represents mutually exclusive events? Is it the one on the left, or is it the one on the right? Now we know that mutually exclusive events do not share any outcomes. So the one on the right are mutually exclusive events. The one on the left are not mutually exclusive events because they do share something in common. Now, how can we calculate the probability of getting event A or event B for something that's not mutually exclusive? This is the same as A in union with B. And it's equal to the probability of getting event A plus the probability of getting event B minus the probability of getting both A and B. That is the intersection of A and B. So So this equation works for events that are not mutually exclusive. Now, that doesn't mean it doesn't work for events that are mutually exclusive, because it does. Keep in mind, for a mutually exclusive event, or events rather, the intersection of A and B will be 0. So therefore, the probability of getting A or B for two mutually exclusive events is simply PA plus PB. If you use this equation, this will be 0 and it will still work. It simply simplifies to the equation that we have on the right if you have two mutually exclusive events. Now let's work on some example problems. Let's use our favorite 6-sided die with a sample space of the natural numbers from 1 to 6. Now let's say that event A represent the outcomes 1, 2, 3, and 4. And let's say that event B represent the outcomes 3, 4, and 5. What is the probability of getting A or B? By the way, are these events mutually exclusive? We could see that they're not, because they share the outcomes 3 and 4. So let's represent this with a Venn diagram. So because they're not mutually exclusive, we need to draw this way. This is going to be A, and this is going to be B. Now, A and B have the numbers 3 and 4 in common, so we're going to put that in the middle. A also has 1 and 2, B has 5. The probability, well, let's write the formula for this first. So P of A or B is going to be P of A plus P of B minus the probability of getting both. Now, what is the probability of getting event A? There's 4 outcomes that relate to event A out of a total of 6 potential outcomes. So it's going to be 4 over 6. Now, what about the probability of getting event B? Notice that there's 3 outcomes that relate to it. So it's going to be 3 out of 6. If we were to ignore this part of the equation, notice that if we add these numbers, this would be 7 out of 6. And this is not possible. The probability of any event occurring cannot be more than 1. It can't be greater than 100%. So that's why this part of the equation has to be there. We have to deduct the events that occur in common. Otherwise, we'll be counting 3 and 4 twice. So the probability of A and B occurring represents 2 outcomes out of a total of 6. So it's 2 over 6. So if we add 4 and 3, which is 7, and then subtract that by 2, we get 5 over 6. So that's the probability of event A or B occurring. Now let's see if this answer makes sense. So what is the union of A and B? What is the sample space for that? A has the numbers 1 to 4. B has the numbers 3, 4, and an additional number 5. So the sample space of A or B is the numbers 1 through 5. So to calculate the probability of A in union with B using this, we have 5 favorable outcomes out of a total of 6. So we could see why the probability is going to be 5 over 6. So hopefully this equation makes sense. Now you see why it works the way it does. Now let's add a new event in this problem. We're going to add event C. And C is going to have the outcome 6. What is the probability of getting B or C? So let's write out the formula. This is going to be the probability of getting B plus the probability of getting C minus the probability of getting B and C. Are these events mutually exclusive? what would you say? Notice that B and C do not share any outcomes. So this is a mutually exclusive event, B and C. So if we were to draw a Venn diagram, it would look something like this. This would be B, this would be C. B has the numbers 3, 4, 5. C has the number 6. So these two circles should not intersect because there's nothing in common. The probability of getting B is going to be the 3 outcomes that it has out of 6 potential outcomes. The probability of getting C is 1 outcome out of 6. Now the probability of getting both B and C, that's going to be 0 because there's nothing in common. So for the entire event is 4 over 6, which is 2 over 3. So anytime you have a mutually exclusive event, the probability of those events occurring will always be 0. So keep that in mind. So thus we have this formula. P of B or C is just P of B plus P of C if it's mutually exclusive.